Okay, example number 3, we have the indefinite integral of 3x dx. We're first going to apply rule number 2, and then we'll apply rule number 5. So rule number 2 says that the 3, that constant, that coefficient, can move to the front of the integral sign. We're going to have x to the first power, and it's the integral, the indefinite integral of x to the first power. That's where we're going to use rule number 5. So rule number 5, that 3 is still going to be multiplied now by the indefinite integral of x to the first power. So that's going to be x to the 1 plus 1 over 1 plus 1. So let's look at rule number 5. Rule number 5, we're going to take the existing exponent, add 1, and then that new exponent, this new exponent is going to be the denominator. Okay? So we add 1 to the exponent and then divide by that new exponent. And that's going to give us 3x squared over 2. And then, of course, we always add c for our indefinite integral. We can check our answer by finding the derivative. So let's check our answer by finding the derivative. 3x squared over 2, we would multiply by 2, subtract 1 from the exponent. The derivative of a constant is 0. The 2's cancel out, and there you go. We have 3x, which is exactly what our integrand was. Sorry about that. Okay, let's try another. And maybe you feel comfortable trying this next one. So go ahead and press pause. Now if you're back, I'm going to work this out. The 5 goes to the outside. And then I have the integral, the indefinite integral of x dx. And that's equal to 5 times, again, the integral of x to the first is going to be x to the 1 plus 1 over 1 plus 1, which is 5x squared over 2, and then we add c. I'm going to erase, since we have a video and you can always hit rewind, I'm going to erase that so that I have a little bit more room to write my answer for this problem. So hopefully you got 5x squared over 2 plus c. Okay, let's step it up a little bit. Example number 4, we have the integral of 1 over x squared dx. Now we're just working with rule number 5. Rule number 5. What I'm going to do is I'm going to rewrite this as x to the negative 2 dx. You might remember when we were finding derivatives, we did the same thing. Now we're going to go backwards and we're going to again make our fraction a negative exponent. And now I can apply rule number 5. I take the current exponent, I add 1, and then I divide by that new exponent. And that's going to equal x to the negative 1 over negative 1, which can still be simplified to be negative 1 over x plus c. Do we need that plus c? Absolutely. Without the plus c, it's not correct. The indefinite integral always has that plus constant at the end. Okay, let's try another one. We've got the integral of x to the negative 3 dx. And now I'm going to skip some steps. So I'm going to take x, and I'm going to take my current exponent of negative 3. I'm going to add 1, and then I'm going to divide by that new exponent of negative 2. That's going to equal negative 1 over 2x squared plus c. Now, if I'm not sure if that's correct or not, because now it's starting to look like, I'm not sure if I got that correct. How can we make sure we have that? Well, we could take that x to the negative 2 over negative 2, and we can find the derivative of it, right? D dx. And we should get back to 1 over x cubed. So d dx of this is equal to negative 2 times x to the negative 1. So sorry, next to the negative 3. We subtract 1 when we're finding the derivative, over negative 2. Negative 2 divided by negative 2 cancels out, and we get back to x to the negative 3. It works. And I would recommend going nice and slow, and on a few of these, checking when you're finding the derivative. So when we're finding the indefinite integral, we're adding 1 to the exponent, and when we find the derivative, we're subtracting 1 from the exponent. You've been finding derivatives for so long, you're going to find it challenging at times to go back and forth between finding the derivative and finding the indefinite integral. Okay, let's have you see if you can try this next one, the integral of the square root of x dx. And I started this by rewriting as a rational exponent. And then I'm going to actually compute the indefinite integral by adding 1 to 1/2 and then dividing by that new exponent of 3/2. That's going to give me x to the 3/2 dividing by 3/2. Dividing by this 3/2 is the same thing as multiplying by 2/3. And then of course, we always add c at the end for our indefinite integral.